All right. So automobile batteries use 3.0 molar H2SO4 as an electrolyte. I'm actually really liking this little line that's going through my screen, even though I should hate it because it lets me set the brush size. Sorry about that tangent. Anyways, automotive batteries use 3.0 molar H2SO4 as an electrolyte. How much 1.20 molar NaOH will be needed to neutralize 225 milliliters, again really quickly, that's 0.225 liters, of battery acid, which is this. Quick side note, you want to write out the reactions for these, but it can be a lot faster than like having to sit there and think and balance these. A lot of your monoprotic acids, which means they have one hydrogen, like nitric acid, hydrochloric acid, that kind of stuff. It's just going to be 1-to-1 ratios across the board. Now, unless you're talking about something that has two hydroxides or something, like MgOH2, then it's going to be 2-to-1. But if it's all straight 1-to-1, it will look like this: HX plus Y. This will be your anion. This will be a cation. OH will react to give you YX plus H2O. Now that's going to be your monoprotic. Diprotic acids, like this guy right here, will have the general reaction H2X plus YOH, 2YOH, will give you Y2X plus 2H2O. Now, remember, if you do get stuck, can't remember this, just remember to write H2O as HOH. It makes it a lot easier to see. Okay, going back to this one then, we're going to use this general right here, but H2SO4, I'm going to leave out the states just to save time. It's 2 NaOH react to give me Na2SO4 plus 2HOH. And the reason you write HOH, because look, you get an H from here and an OH from here. So if I have two H's here, I'm going to need two OH's from here, which will give me two HOH's or two H2O's. Anyways, so your ratio is going to be 2-to-1 here. Okay, so we're going to go ahead and start with 0.225 liters of H2SO4 times 3.0 moles of H2SO4 per liter. That's a 2. Started writing an S. Times 1 mole of H2SO4 will give you 2 moles of NaOH, or will require, not give you. And then we have 1.20 moles of NaOH per liter, right? And that comes from this molarity right here. So when you do all of that lovely math, you wind up with a nice clean 1.1 liters NaOH. Cool. So on to the next one. What mass of hydrogen gas is produced when this mass of zinc dissolves in this mass of that molarity hydrochloric acid? So you're given essentially a mass and a volume and a molarity. So you have two things to compare here. So this is actually a limiting reactant problem. So let's set it up as so. 7.35 grams of zinc times 1 mole of zinc is this many grams of zinc. And that is, where do I have it? Oh my gosh. 65.5 0.38 times 1 mole of zinc will give me 1 mole of H2. 1 mole of H2 is about 2.016, yeah? This is 1.0079, yeah, grams of H2. And then for the other equation that we're comparing, we have 0.500 liters times 1.200 moles of HCl per liter times 2 moles of HCl, 1 mole of H2 times 2.016 grams of H2 and 1 mole of of H2. Okay. So when you do the math, here you get 624, and here you get 0.227 grams of H2. So you want to choose the one with the smaller number, which is that bad boy right there. Okay, on to number 18. How many grams of CaCl2 are formed when 0.02500 liters of this molarity calcium hydroxide reacts with excess Cl2 gas? This word excess right here is a word you would love to see so you don't have to work out limiting reactant. So all we have to worry about is this bad guy right here. Looks like we're balanced because I see coefficients and it doesn't say anything about balancing. So okay, 0.02500 liters times 0.00237 moles of CaOH2 per liter times 2 moles CaOH2, whoops, will give me, what are we going to? It's calcium chloride. 1 mole of CaCl2 times 1 mole CaCl2 is 110.986 grams of CaCl2. When you do the math there, I got 3.29 times 10 to the negative 3 grams of calcium chloride. Let's check our unit cancellation just to be safe, even though I know it's good. Liters, moles, grams. Cool. We're good to go. All right. I think that about wraps everything up. Let me know if you guys have any questions, please. And I hope you guys have a good rest of your weekend if you watch this. If you don't, I hope you do too, but you won't hear that. Bye.